This week we will be learning about recursion, which is a very interesting topic. You can think of recursion as a type of loop, but it's a little bit more than that. We're going to get into efficiencies and inefficiencies and all of that stuff. In this particular video, I'm just going to walk you through a few PowerPoint slides before we get into some actual coding examples. Before I do that, I want to make a note that most of these examples I will give you a non-recursion version and then a recursion version of the task that we are going to do, the program we are going to make, is probably going to be, this is how we do it without recursion, now your task is to do it with recursion. And of course, I will always, as always, give you a video solution. I have created several recursion activities. You can find this sheet on Blackboard if you'd like to work through them. And as always, every video that I want you to try yourself will be labeled activity. If you're struggling, the solution will be available. So let's jump right into recursion. So I was originally going to include APIs this week, but I think that I'm going to push that to next week and we will focus on recursion for this week, and then we'll get into some fun API stuff. So a note for this week and next, a lot of what we will cover cannot be conveyed in a slide, although some of it can. The majority, as always, I guess, is going to be in-class examples, videos, lectures, hands-on practice. That's how we learn this stuff. I can show you what it means in a slide, but it doesn't mean you're going to grasp it right away. It's really hands-on experience where you're going to learn this stuff. And as always, that can be found on our Blackboard course site. We're going to learn about what recursion is, a look at it, do a lot of activities involving it, and then the difference between direct and indirect recursion we will talk about. So this is a good picture of what recursion is. Recursion, here we go again, recursion, here we go again, recursion, here we go again, and just keeps going. Recursion is essentially an infinite loop. You can think of it as a method that calls itself, which would be an infinite loop because when does it stop? Well, it does stop, and we're going to learn how, why, when. So recursion is a method of solving a problem where the solution depends on solutions to smaller instances of the same problem. Some common examples of this that we are going to look at are factorials and the Fibonacci sequence, and anything where the step-by-step solution gets smaller or bigger as you go. You repeat the same process again and again and again and again until you stop. Recursion can be used there. It's a method which calls itself, which is a strange concept when you first hear about it, right? A method that calls itself. We know methods can call other methods, like constructor chaining, right? In superclasses or inheritance, you can have constructor chaining. You can also have a method which calls another method, which calls another method, method chaining. But we've never really seen a method which can call itself. This can happen because, of course, if a method can call a method, why can't a method call itself? It can. We will discuss the differences between direct and indirect. Efficiencies, we will see why recursion most of the time isn't the most efficient option. It can be, but most of the time it is not. And you can think of it as a type of loop. That kind of makes it a little less daunting, thinking of it as a type of loop, because it is, right? It calls itself, therefore it loops. So we're going to write this program in the next video, but let's take a quick look. Think of recursion as a loop, but if recursion is a method which calls itself, then how does it stop? If a method calls itself and its job is to call itself and it calls itself and it calls itself and it calls itself, is that not an infinite loop? Yes, it is. It's much like what we see here, this sum loop method. While 1 is less than 5, and notice there's no variable for this, how long will the number 1 be less than the number 5? Forever. This will go forever and ever and ever and ever and ever until your computer crashes. That's an infinite loop. This is not recursion, this is an infinite loop. But you can imagine that's what recursion would do, and this is an example of that. Yes, a method which calls itself would, in fact, be an infinite loop, as seen here, unless, but before we get to the unless, we have a method called sum recursion, which takes an integer of n, where it says this will also happen forever, and after that, it calls sum recursion. Sum recursion hits the curly brace, comes back up, calls sum recursion, takes n, says this will happen forever, calls sum recursion, takes n, this will happen forever, sum recursion, n, this will happen forever, it keeps going and going and going. You have an infinite loop, just as we did over here. So this is a prime example of recursion, a method which calls itself. See that? Now, how do we know when to stop? That's what we're trying to get at here. This is something called a base case. often referred to as a base case. To avoid the infinite loop situation that we have with recursion, we can implement what is known as a base case. A base case is a simple if statement. That's all it is. That tells the program, if this happens, if we get to this particular scenario, if n reaches this, something like that, stop calling yourself. So under this condition, keep calling yourself unless this happens. That's it. We tell the program when to stop. Otherwise, keep going. So here, as we will see in the next example, we have a sum recursion method which takes an integer of m, and we say, if n is 0, you should return, which just means basically like a break. Just return nothing, stop. Right? If you return nothing, you stop. So if n is 0, return. You could essentially remove the return, it would just do nothing, that's fine, but return gives it something. So if n is 0, stop. Otherwise, and we don't need an else here, otherwise, this will also happen forever, which is not true now. Sum recursion base case n minus 1. So let's give this as an example. Let's see, 1, 2, 3, 4, 5. Let's say we get n 5. So we call sum recursion. It says, is n 0? No, it's 5. This will also happen forever. We call sum recursion. We take n and give it n minus 1. We call it with 4. Is 4 0? No, it's not. This will also happen forever. We call sum recursion. 4 minus 1 is 3. And then it's 2, and then it's 1, and then it's 0. Is n 0? Yes, it is. Return breaks the cycle of recursion here. The base case allows us to exit the recursive method call. So I'm going to show you this very example using this, this, and this. Watch out for that in the next video, and then we will continue on with recursion and do plenty more examples.